Bismillah ar-Rahman ar-Rahim wa salatu wa salamu ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. Okay, so today, so far we have covered most of the ROS2 concepts from conceptual perspective, what we call as the ROS computation graph. We know what is node, what are nodes, topics, services, actions, parameters. We know how to get them, how to deal with them. And of course, ROS provides different APIs in order to write code to control robots, to control drones, to control any kind of autonomous and unmanned systems. And today we are going to start with the Hello World application in ROS, which is writing a simple publisher and subscriber to show how we can exchange messages between different ROS nodes. And always remember, ROS is similar to a network. So it's basically a network where you have different nodes who will exchange messages together. And in these networks, every node will be able to take actions to get sensor reading from the environment and manipulate them and transform all this, the data manipulation information to a specific action to make the robot move or grasp object or fly, depending on the robot application. So in order to write a publisher, we will follow 5 steps. Very simple. Okay, if we want to write a publisher subscriber, we need to agree on a topic name, صح ولا? Okay, because we need to have a common topic. And the same topic will be used both in the publisher node and also in the subscriber node. Okay, give me a topic name that we have used before, for example, to make the robot move.
Talk to the same node.
Yeah, we have, this is a node, I'm talking about the topic. Like CMDVAL. CMDVAL, it was the topic that we have used in order to communicate between the Turtle SIM node and also the teleop node. The teleop code node will send commands over the CMDVAL, and then the robots, when it receives this command, is going to execute. And we are going to agree on the common name for the topic to publish, determine the type of message that the topic will publish. In case of CMDVAL, we have the twist message. Now we are going to use a very simple message type, string. Just we are going to send a string from one node to another. And determine the frequency of the topic publication. When we send, I can send 1 message per second, or I can send 2 messages per second, or 10 messages per second, or 100 messages per second. So the frequency, it depends on the requirement of the application. It means how many messages I will send per second. And finally, we will create the publisher object with the chosen parameters. And we will keep publishing the topic message at the selected frequency. Yes?
Topic echo, right?
Yeah, topic echo, this is just to hear the messages that are, yes, keep hearing the messages that are being sent between the publisher and the subscriber, or the client and the service. Okay.
From terminal.
From terminal, yes, it's only from the terminal. Now we will do it from programming perspective. Okay, and the same thing for the subscriber. We need to identify the name of the topic that we are going to listen to, and the publisher and subscriber should have the same name of the topic to be able to exchange messages. Identify the type of the messages to be received. We define a callback. And now try to understand the callback. The callback, it's like a function that is related to a thread that will be executed when there is an event that happens. What will be the event for the subscriber? What will be the event for a subscriber? A message that is received. A message that is received. This is an event. So whenever a message is received, there is a function that will be executed to process this message. This function is called callback. Okay, it's like someone in sleep. When it hears something, it will wake up. Okay, so this wake up is the callback function, which will be responsible for processing the data incoming to the subscriber. Yes?
Is it like a response to the...
Yeah, it will do a response. The callback will execute some data. Okay, for example, you have received laser information. Okay, when the laser information is received, the callback will take them, process, and will say there is an obstacle after 1 meter. Okay, so take decision. Would you like to stop or to continue? Okay, so this is the concept of a callback. It's like a thread that is executing in parallel that will allow you to process incoming data, okay, in real time. And finally, after defining all of this, we will start listening. start listening, it's like you have a TCP server that will be just listening for incoming messages and spinning forever.
If you can bring it, identify.
Okay.
We don't have.
Look now, this is a very simple application. We are going to use a talker and listener. What is the topic name here? Chatter. So we'll define a topic name that is chatter. So chatter is the topic that will be used in the publisher, which is the talker, and it's also the topic that we will use in the subscriber, that is called the listener. Okay, what is the message type?
String.
It's a string. Yes, standard message slash string. So it basically is going to send one field in a data that is called, okay, hello world, and then I will put a number, I will increment a number for every message that will be sent. As simple as this. Okay. Writing the publisher. Of course, we've already done this. We need to have a Python package that is created, because we're going to do that in Python. Okay, now you have already a package, right, that you have created before. You are ROS2 Essentials Python. Okay, and this is the code that we will be writing. Okay, I can explain the code here, but since this is the first time, we're going to jump into our VS Code and try to work on this. Okay, look now, let me close and open again. This is our workspace. And inside the workspace, you have SRC, and here we have two packages. Now I'm going to develop a Python script where I should do that.
In the Python.
Okay, here. Okay. And inside this Python, I have to make it also here. I have now only the hello world that was initially created. So I want to create another file here with, so instead of doing all of this manually, what we should do, we should open VS Code. Okay, let me close all of, so I will start from, okay, let me create a new window. So in principle, you have a new empty window like this and no folders. Okay, so you have two options. Now I would like to bring all the dev working space. You can drag it here if you want, or you can make open folder here. It's like you want. You can also clone a GitHub repository. By the way, inshallah, next week I will put everything in GitHub repository, and we will work from the GitHub repository. It will be much easier. Okay. Look now, we have all the working space, all the workspace over here. We are going to work inside SRC, and here inside ROS Essentials Python. So this is where we are going to add our script. واضح? I want that you do the same thing. Can you follow with writing the code, or it's difficult?
I think it's difficult to follow up and listening. And
Okay, خلاص. Okay, you can follow me, and I will give you the recorded video. Try to do the same thing afterwards, okay? Because for the first time, I want to show you all the steps in all the details, okay? So later on, you will be able to manage yourself.
So, Doctor, just a question. At the beginning, before we do start to work on the Python code,
Yes.
we establish our workstation, our workplace,
Yes.
make the packages, and after that we open the VS Code, right?
It's called workspace.
Workspace.
Sorry,
Yes.
workspace.
You make the workspace. You
The
create.
first thing is making the
You create
workspace
your package, and then you open VS Code.
and drag this package to it.
Yes. And put everything here. في شيء محمد? Okay.
I need to download any other things, or just
What is inside
when I do the workspace, everything from there, everything from virtual machine will be done on its own.
You have to do the same things that we have done in the previous lectures.
Which is, oh, okay, so declare the workspace.
Yeah. Now we complete the installation, we complete the configuration, we did the workspace, we did the packages, we understood what is ROS ecosystem, computation graph. We are ready to go with programming. Now this is the first exercise. Okay, look, I have everything that I have created before. Okay, and I'm going to create my first Python script. So very simple. I will come here and I will make a new file, and I will call this talker.py. It's an empty file. Of course, I don't memorize all the code, although I spend now several years with programming. So I'm going to open the tutorial, and you have to do that also. Okay. So later on, when you want to change, it's simple. We always start with the sample code, and then at the end, publisher, subscriber, you change the topics, you change the frequencies, you change the different buffers, and that's it. Okay, let's make ROS2 Foxy and publisher, subscriber. This is in Python, yeah. I will get this tutorial. And inshallah, next week I will also introduce Humble. You will work on Foxy, I will work on Humble, and you will see that there is no difference for the main things that we will be doing here. Okay. Just it's a matter of your version. Okay. So, first of all, we need to create a package. You already did it here. It's called publisher subscriber. You can do it in any package. We have already ROS2 essential Python. This package is meant to put all our code that we will be working on. And okay, now this is the code. I can copy paste the code, it's simple, but I will do it from scratch. Okay, now first of all, we need to import the ROS2 Python library, which is RCLPy. Okay, you do this like you import any other Python library, there is nothing. And then we will import node. Okay, so from RCLPy dot node import node. Of course, in Python we can do this, and if we import only RCLPy, this will have an implication of making, if I want to declare any new node, okay, I need, for example, like here, instead of writing node, you will have to write rclpy.node.node. Instead of doing all of this, okay, this is like the namespace. We declare it, and we can use just node safely because it's already imported from the corresponding package. And as you see in this example, we are going to use the message string. So I'm going to import the string message. I'm going to import the string message, and the string message, we have already seen that it belongs to the package standard messages. Okay, std. If there is anything that you don't understand or maybe you forget, just ask me. Okay, import string. Does these three lines make sense to you?
Is it message.message?
.msg, yes. You look at it, makes me an error here. So this way we did it in ROS1, and this way we do in ROS2. And there is a reason here. in ROS1, messages and SRV files was considered as two different things. In ROS2, they are considered the same thing as all being interfaces. Okay, and these interfaces, they are two types, MSG and SRV. How do I know whether this is an SRV or an MSG? It's based on the folder where it is located. But at the end, if you look at even the tutorial here, they provide them as interfaces on how to create custom messages or custom SRV files.
So
This is from. Yes.
if I don't want a message to be string, if I want it to be float, double, or integer, I need to do the same thing but replace string with the type I want.
It's not you want, it's what is available. Now, for example, if I go here to ROS/ops/ROS Foxy, and what it was, I think in Leap, maybe in Leap, and I go to standard MSGS. Yeah, it's not in Leap, maybe in share. I think it should be in share. FSTD MSGS. Okay, you will find MSG file. Okay, all these types you can use them in standard MSGS. Okay, you have unassigned int 16, you have float, you have different type of types that you can use them here. For example, now I have char. Okay, char. I can use char over here if I want to use only one character. Okay, but we are going to use it for a string. Okay, and now, in ROS2 it's mainly object-oriented, although there are 3 different styles on how you can write code, and you can review this in my ROS2 Udemy course. I present 3 different styles, like the legacy style that was in ROS1, which is just writing a script, and the object-oriented. There is a 3rd style, I don't remember what's its name, membership function or something like this. There are 3 different styles, but it's because this was in the beginning, but now it seems like the standard to work with Python in ROS2 is to use object-oriented. Okay, and this is why, but I can do the same thing without having object-oriented. Object-oriented is just a style on how you can put your code. Okay, let me create something called minimal publisher. I can call it Talker. Okay, Talker publisher, just to have something different. And here we will make inheritance from node. Okay, if I don't do from RCL node import node, I will have to write RCL py.node Control S. Okay, and I can even remove this one. It should work because this RCL py was defined, but of course this is not going to be fancy for a complete code. Okay. So we're going to create a constructor. I find Python intuitive in everything, but not in object-oriented. I mean, if you learn object-oriented with Java, this is actually the real language for object-oriented.
Yes.
Yeah, it's made for this. But Python, it's not really for object-oriented because it's kind of very flexible, and object-oriented should have like kind of a rigid structure. And this is the same for all scripting languages, including JavaScript and others. Okay, let me call it Talker Publisher. So this is the node initialization. Okay, so super here, it refers to what? Superclass node. It's the node, yes. The node, we will initialize the node.
Oh.
Yes.
Did you put double underscore?
Yes.
Yeah.
Yeah.
How does that work?
I put here def double underscore in itself. Yeah, same as here.
So it's both double underscore.
Yeah, double underscore. And then we are going to create a new function that is called publisher. So it's defined as an attribute, okay, as an attribute function. And here it will make self dot create. From where it comes this dot create publisher? We don't have anything here in self. So self is like this in Java. Self is similar to the this keyword in Java. We've taken, yeah.
But that means it's come from library outside of the.
Mm-hmm.
Is it from because there is a parameter in it initializing which is called self?
No? Self, so here, create publisher. This is one of the functionality of a node. And here we are inheriting from the node superclass. So the node superclass has, when you make inheritance, you inherit all the methods and you can use them inside the subclass, right? Okay. So
I think it doesn't even have to be called self. If you change it to something else and be consistent, it will be the same.
look, if you remove this,
No. If you change self to OBG, for example, or this, it doesn't matter.
No.
But you have to, in the construction of init itself.
yeah, yes.
You have to be consistent and use the same keyword.
Ah, here you mean?
Yes.
Okay, yeah, okay.
And then the last one is this.
But look, the color style is not the same. I don't know. I think self is a keyword in Python.
I use it definitely,
You used in object oriented?
but without self. Yeah.
In object oriented.
Yes, like this.
Okay.
I don't know if this is different. It doesn't show you an error, right?
It doesn't show an error, but I don't know whether it's going to have the same functionality. Something I didn't try, but it could be good to try. Because, yeah, it seems to work right. Okay. So what we should here, so the functionality of the parameters of a publisher, we need to specify the type, the name of the topic, and the buffer size. Okay, so this is the topic, this is the type that you have defined here, and this is the name of the topic. I'm going to toggle chatter.
This I can change it to whatever I want, right?
Yes, you can put whatever you, but what you put here in the publisher, you have to also make it in the subscriber. If you make a different topic name, they will not be able to listen to each other. Okay. So you can think about the topic name is like the radio frequency that two persons choose to communicate with each other. Talkie walkie مثلا. If they don't have the same frequency, they are not able to communicate. Okay. And then typically we put 10 as the buffer size. Now we are going to create a timer, and timers, it's something completely different to what we have seen in ROS1. So now in ROS2 they introduce a function that is called create timer. I thought Saqif was trying to use sleep. I don't know whether you will be able to. Yeah, I didn't try to use sleep here for in the same way that used in ROS1, but this is now the recommended way on how to create a timer. Self dot timer, okay, self dot create timer.
So the first you need to specify the timer, type timer.
Yeah, so the timer period here, okay, I can create it as a variable or a constant. Timer period equal, what does it mean 0.5?
That means it will send a message, two messages every 1
Yeah,
second.
so it means 2 hertz. If we use this is in second, it means 2 hertz. Hertz, it means number of iteration per second or number of messages per second. Okay, so this is here the timer duration and self timer callback. Okay, so what does it mean timer callback here? What will represent this one, this function?
Like when the timer ended or
So it will keep
So the same concept as the callback, yes. A callback, it's a function that will be executed when an event occurs. لما نستعمله في subscriber, when we are going to use it in subscriber, the event will be a new message that is received. When we are going to use it here, what's the event? The timer has fired. Okay, so it will be executed to execute the logic, because when the timer has expired or fired, you want to execute something. Okay, and it's here where you are going to process your message. So what we want to execute here, we want to publish. If the timer expires, I want to publish a new, okay, one more message. So I'm going to create here def timer callback self and okay, so we're going to define a string message. So this is how we create a string message, an empty string message. And the string message itself, now if I go back to the string message defined, it has only one attribute, which is called data, okay, of type string. So what I will do here in Python, we will do msg dot, it's the data I'm going to access. We can have multiple fields or multiple attributes of the message, but here now we have only one. Okay, so I will fill this one with some kind of string message. I don't need this anymore. So I'm going to do hello world. And it will not be bad to put a counter that will be increment for every new message sent. We'll make a counter here. Person self dot counter. So we can define the self dot counter to be incremented every time. In principle, it should be initialized. Yeah, it should be initialized in the constructor to the value of 0. And every time we're going to send a new message, I'm going to make Control V. Plus plus. I don't know whether this is like the, okay, let me make it in the very basic manner. +1. I'm not used to this Apple keyboard. Okay. But before doing this, we need to publish. So I'm going to create the self.publisher. And I will call the publish method. So here effectively is going to publish the message through the topic chatter. Okay, and I can make now the logger. So instead of using print in you can use getlogger.info, which is defined in ROS2. Is getlogger defined in ROS2 or it's in Python in general?
Yes, there is, but
You can
it's
only
there.
type when you print as well. If you just want
What? What is getlogger here?
yeah,
Third
third
one.